Hello everyone. The Dharmapal. Hi bro. Abhi 1221. I don't know why your message got retracted. It's okay. Uh, right. Let me know how many of you have solved all the four problems in this biweekly contest. I know it's hard. The fourth one was quite hard, and it goes with 4D DP, four-dimensional digit DB. That too. So let us start with the first problem of this biweekly contest 185. Let's start with the first problem. If you look at the problem, you are given with two integers m and n. This is quite easiest problem in the whole contest. That's the first problem, right? And the second one uses line sweep, and the third one is nothing but a DP problem. The DFS plus DP. Excuse me. Right? So create grid with exactly one path. You are given two integers m and n representing the number of rows and columns of a grid. Construct any m by n grid consisting only of characters dot and hash. Now dot represents SL, hash represents a abstract. Now you need to start with the top cell and go to the bottom right cell, right? It will move only right or it will move only down. Imagine, imagine you have a grid like this, m by n, m rows and n columns, which will start at the top left, which is nothing but 0, 0, and end at here. Now, it should go either right or either down. So, our intuition is just imagine what they have given. Let us just go with the problem. Return any grid. They said any grid such that there is exactly one valid path from top cell to the bottom right cell. They said exactly one valid path. There should be no other path, right? Let us take an example. We are given with m is equal to 2 and n is equal to 3. So there are actually three columns and two rows. Now we need to start at this cell and we need to end at this cell. There are, number of possibilities. I would not choose this possibility which is already given in the problem. But what I would do instead will place a dot here and then here and then here and then here. And I would do that no matter how many what the m or n is. Now, if m is equal to 1, nothing but there is only one row, then what I need to do is this is the top left cell, right? This is the top left cell, and this is the bottom right cell. This is the top left cell, and this is the bottom right cell. I need to reach here from here. So what I would do, there is only one path, so I would put everything as top. Now imagine I have only one column and I don't care about the number of rows. So what I would do, I would place again, what is the top left cell here? The first cell. What is the bottom right cell? This one. Bottom right top cell is this one and the bottom right is also this one. I need to reach from here to here. So I would place every cell with dot, right? Now, no matter, as I said, no matter what is M or what is N, I would do only one thing. I would place the dots. I would place the dots in first column. First column will be dots, nothing but I am creating a path there. Last row will be dots and remaining all are hashes. Remaining all hash, right? So that's how I create a valid path from the top left cell to the bottom right cell. Just like the first column should be make first column or all cells in first column as dots. It would be better. All cells in first column as dot and all cells in last row as dot. That's how we create it. Now, one thing, excuse me. One thing here, if m is equal to 1 or n is equal to 1, we need to return string like this, right? So return string of n, which is nothing but we are returning a string. We are returning a string, vector of string, nothing but every row should be string. This should be a string dot hash hash hash. Then this should be again dot hash hash and then hash. This will also be dot hash hash hash. That's how we solve this. I hope you understood this problem, right? That's the first problem. And if you have any doubts, please let me know about the first problem in biweekly contest 185. Just now we have solved that problem. It just it just took me 10 minutes, but let me also give you how do I code this. If m is equal to 1, return string with the size n and everything as dot. If n is equal to 1, there is only one column, right? So we'll create a vector of string answer. Now, I would push a string with only one dot for how many times? M times. So for I is equal to 0, I is less than M, I plus plus answer dot push back a string which has only dot. Now, imagine it is not M is not equal to 1 and it is also not equal to 1. What I would do? I would create a vector of string of size. What would be the size? There are m rows, right? Each row needs a string. So m rows. So answer with m, right? And I think I should also have everything as hash. Yes, I have also created string n comma hash. So m comma string of n, everything will be having hash, right? Everything is initialized with hash. Then make first column, this one, the first column, right? The first column, this one, as make first column, make every cell in first column. It would be better. Make every cell in first column, every cell in first column as dot. Nothing but I am creating a way. Make every cell in last row as dot, right? So the first column and the last row is made as dot, so that we are just creating a path from there, right? Let me show you that. Hi, bro, World Destroyer. Let me know your name, Destroyer, and also how many problems have you solved in today's contest, right? So today's contest, the fourth one was very tough, the digit DP one, and it takes 4D DP, four-dimensional DP, um, which stores the position and also whether is it visited or not, and also there is something like type which we use in digit DP. I will also explain when we go to the fourth problem. But if you have understood Adi, Adi, nice name, right? Let me know where are you from and how many problems have you solved in today's contest. I think the fourth one only the the one which is much harder, right? At least we can try the third one. Now let us look at the second problem if you have understood the first problem. And if you have any doubts, please let me know in the live chat. I'm about to start my journey of DSA. What would you suggest me? Bro, let me know your year, college year, right? Let me know your which year are you in your college? Hyderabad. Okay, which college? From Hyderabad, which college? Right? I think there is some error in this, some issue in LeetCode. Okay. Minimum lights to illuminated road. This is classic. What is this sweep line algorithm? Right? Adi. Your name is Adi, right? Okay. And if you have already solved sweep line algorithm, then it would be easier for you. If I could say, let me tell you, there is a problem. Yeah, meeting scheduler, I think. I completed my first year right now. That's good, bro. And all the best for your second year. I'm from Vardhaman. Yeah, it's a good college. And let me know what is your opinion about your college. And let me tell you what we can go with DSA as you are a beginner. And first, you can follow me in Instagram. This is my Instagram ID. You can search there, and there will be a roadmap. I'm telling you, there will be a roadmap of DSA. In the post, I think I have pinned that post, right? I solved unknown. I solved three, but last one was adjacency DFS, which I can't get, but I implemented it. Okay. Okay, you have implemented adjacency DFS. Okay. There will be a roadmap of DSA. And let me tell you, if you are okay with arrays, strings, hash map, hash map, and also there are other things. After this, it would come stacks, queues, and there are also, uh, you know, monotonic stack, something like that. Yes, you can DM me, bro. Adi, right? Your name is Adi, right? So this is just an introduction of how we can go with the DSA and start with patterns, printing patterns, printing patterns, right? It can Adi. Yes, I got your request. Wait a second. Wait a second. Right? And meanwhile, yes, I got your message, Adi bro. Okay, right. I think we can go to the second problem, right? And if you have any doubts on your first problem, please let me know, right? I hope we are good to go. Unknown. Let me know your name, bro. Unknown 070, right? Yes, I think we can go to the second problem. Here, here it is nothing but we are given with some indices like 0 to n minus 1, 0, 1, 2, 3, 4, and so on till n minus 1. If I have, if this is nothing but lights, this is the array we are given with. Let me explain you the problem, the total problem, right? These are the lights given for us. If lights of I is 0, just neglect it. For now, just neglect it. If lights of I is greater than 0, if it is not 0, it is greater than 0. Let me tell you, here I have, sorry, I'm buildings, right? So if I have 2, let me tell you, this can light this one, and also this one, and also this one, and also this one. Why? Because if lights of I is greater than 0, uh, that illuminates every position, excuse me, that eliminates every position from maximum of 0 comma I minus v, where v is equal to lights of I minus v, to minimum of n minus 1 comma I plus v. Why I'm saying n minus, why they gave us n minus 1 and also 0? Why? Because imagine instead of 2 here, I have 5. Then I can only eliminate till from 0, right? I cannot go from 3 minus 5. What would be 3 minus 5? Which would be minus 2. I cannot eliminate minus 2, right? In there is no index, such index. So let me know how many of you have solved this. This is the classic sweep line algorithm. We can just apply that sweep line algorithm. If you have solved that meetings scheduler, something like meetings scheduler, you can easily solve this. Now, instead of this, let me have here 10. Instead of n minus 1, let me have 10, right? 10, 9, 8, 7, 6, and then 5. Now I have 3. Imagine I have 3. Then I can eliminate this one and then this one. I can eliminate from minimum of n minus 1 comma I plus 2. N minus 1 is nothing but 10. That's the last index, right? N is equal to 11, so n minus 1 would be 10. From minimum of n minus 1, I plus v. I is 8, 8 plus 3. V is something but 3. 8 plus 3 is 11, but I don't have it, so minimum of 10 comma 11 would be 10. So till there only I can illuminate the lights, right? So the problem is, if it is 0, lights of I is 0, I can illuminate this one or this one. Positions from max of 0 comma j minus 1 to minimum of n minus 1 j plus 1. Nothing but the previous one and the next one, and also the current one. This one, and this one. Nothing but if lights of j is 0, then maximum of 0 comma j minus 1, minimum of n minus 1 comma j plus 1. That's it. These are the only two from illuminate from a max of 0 comma j minus 1 to minimum of n minus 1 comma j plus 1. These are the two instances in between I can illuminate the lights. But the problem here is not, why we won't be going with the naive approach. Let me tell you the naive approach here. Naive approach. I'll also code that so that you can understand why I'm going with the better approach. Naive approach here is go to every lights of I, which is greater than 0, and go left and go right and illuminate the lights. Illuminate the lights. Now go to every lights of I is equal to 0. Illuminate lights of I minus 1, lights of I, and lights of I plus 1, these three, right? So if I just code this, if I just write the pseudo code for this, it would be looking like, let me tell you, for int I is equal to 0, I is less than n, I plus plus, if lights of I is greater than 0, now I would go from for int j is equal to I, j is less than minimum of n minus 1, comma, I plus lights of I, j plus plus. Here I would make every light, how do I make, illuminate or not? So I would create a vector of int illuminate. So let me tell you, instead of go to every lights where lights of I is equal to 0, I would do one thing. So imagine I have double zero double zero. Here I need two lights, one light here, and the other light here. Because this one light will ignite this one and this one and this one. But this light only ignites this one, right? So every lights of I go with, I would just go with uh, consecutive zeros. Consecutive zeros. That's it. I would just have vector of int illuminated, where if it is illuminated, it would be having 1. Instead, if not, it would be having 0. Right? For j is equal to I, j is less than minimum of n minus 1, comma, minimum of n minus 1, comma, I plus lights of I, j plus plus. I would just make it as illuminate of j is equal to 1. Then for int j is equal to I, j is greater than, here I will also have less than or equal to, here I would also have greater than or equal to maximum of 0, comma, I minus lights of I, j minus minus. I would just make illuminated of j is equal to 1. Now, how much you think this would be costing us in time? In time wise, it would be costing us, here in a worst case, imagine everything is going to n, right? So imagine 0, 1, 2, 3, 4, and so on, n minus 1. Imagine n is equal to 15 and everything is having a light which is like 15, 12. Imagine just 15, 15, 15, everything is greater than n. Then this would go n here, n here, n plus n, 2n into how many times this would be running? 2n into n. In worst case, 2n into n is our time complex. So this is the worst case, right? I can tell you here I am having one E5, which is much larger. So definitely we are not going with that approach, but for your convenience and we need to have that, we can have that time to exceeded error. Now, let me tell you another thing. The main thing to go with the naive approach is to get the consecutive zeros in our lights, right? In our illuminated array, which is nothing but those indices which are illuminated or have light. If it is not there, it is just 0. Let me tell you, for 4 zeros, how many do you think, for having a 0, how many lights do you think are needed. 1. For 2 zeros, 1. For 3 zeros, 1. For 4 zeros, I would need 2. For 5 zeros, I would need 2. Why? Because these 3 and for these 2, I need another light. Now, a light can ignite 3 consecutive zeros, right? If I place a light here, it would ignite this, illuminate this one, previous one, next one. So to ignite another, I would illuminate another 2 lights. I need another light here. It would illuminate this one also. So imagine I have 6 zeros which are not illuminated. I would place one here, one here. This would illuminate this, and then this, and then this. So 2. How do I get this? If this is n, then I would need n plus 2 by 3. 1 plus 2 by 3, 1. 2 plus 2 by 3, 4 by 3, 1. 3 plus 2 by 3, 5 by 3, 1. So it is nothing but n plus 2 by 3 is the formula. It is nothing but n is nothing but number of lights, number of indices with no light, no light, or number of consecutive indices, consecutive indices with no light, n plus 2 by 3. That's the formula. Now, how do I get it? I would get it by for I is equal to 0, I is less than illuminated dot size, which is also n, I is less than n, I plus plus. I would have zeros is equal to 0, or length is equal to 0. If illuminated of I is equal to 0, then I would just increase ln plus plus. I hope you understood this one, ln plus plus. Now, if it is not 0, then else. Answer plus is equal to length plus 2 by 3. Length plus 2 by 3. Then make length as 0. As we got a illuminated light, so return answer at the end. Right? How do you think about this algorithm? I know this is a naive approach, but even then, this is the brute force actually. Right? How many have you solved this problem? And let me know if you have used another algorithm than this. How many have you solved this problem? And if you have any doubts still now about the naive approach, please let me know. Right? I hope you are clear. I hope you are clear. right? Let me code this up, but before going to the code, please let me know if you have any doubts about this. About the first and the second problem, here we are going with the naive approach or the brute force approach. Right, this is the optimized code. I'll also explain you about this. But before going to that, let me know if you have any doubts about the brute force. Wait a second, right? Let me code this up. I know we would get a wrong answer or the time limit exceeded. Int n is equal to lights dot size, a vector of int illuminated where n with 0. Now for int I is equal to 0, I is equal to 0, I is less than n, I plus plus. If lights, if lights of, sorry, lights of I is greater than 0, then for in j is equal to I, j is less than or equal to minimum of n minus 1, comma I plus lights of I and j plus plus. Here, eliminator of j will be made as 1. Then again for int j is equal to I, j is greater than or equal to maximum of 0, comma I minus lights of I and j minus max. Here, eliminator of j is equal to 1. Here again, int length is equal to 0. I went to left and right for every light which is having lights of every index. I went to left and also right at every index which is having lights of I greater than 0, which is having nothing but a v greater than 0. For int I is equal to 0, I is less than n, I plus plus. If illuminated of I is equal to 0, then I would increase the length. Else, if I got any light in the middle, right, then answer plus is equal to length plus 2 by 3 and the length is equal to 0, right? Return answer at the end, but we need to initialize int answer is equal to 0. How some error of n minus 1 comma I plus lights of I. Uh, there is a runtime error. Sorry, it should be J, right? A small spelling mistake. Okay. Now, if ln is greater than 0, then answer plus is equal to ln plus 2 by 3. Let me run it again. Let me submit it and I'll show you whether it will give me a correct answer or not. Might work. No. If you see I got a TLE, this, as I said already, there will be some test cases like this which would give me big of 2n into n. What it would be, I think 2n into n. Let us just make it as n square. Alright, it would be in n square time complexity and n square for 1 E5 would definitely not run. I'll tell you another method of solving the second problem, the better approach. I'll tell you how. Better, better approach. Imagine, just imagine. Imagine I have the lights array like this. Lights where I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I have a 1 here, 3 here. Or just take this as take this as 3, right? Take this as let's take it as 2. Let me tell you what I would do. As I am having 2, which is nothing but it would ignite here, it would ignite here, it would ignite here, it would ignite here, it would ignite here. Now I have another one which is like 3. This would ignite. Let me take another one. I have 3, or let me take it as 2, right? Here it would illuminate this one, and also this one, right? This 2 would ignite all of this. This 2 would ignite all of this, right? Now what if I have this as one, this as one, this as one, this one, but let me tell you. Here I have 2, right? So I need a 2 here, I need a 2 here, I need only 1 here, only 1 here, only 1 here. How do I get it? Let me tell you, for this index 3, I have 2. What I would do is I would add plus 1 to some array and I would name it as difference array. Difference array. Here, I am adding plus 1 at which index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm having it at plus 1 at index 1, nothing but 3 minus 2, which is 1. Then again, it would I have this one, right? This would end here, not here, not here, but here, right? So I would add minus 1 here. Now at 6 I have 2. So I would have plus 1 at here. I am just placing it. Don't get confused. And minus 1 here. Now let me tell you. Let us do let us do pre-sum for this. Let us do a pre-sum for this, and I will tell you exactly how I would get this vector of int, this array. Now, do a prefix sum run for this. Let me tell you. I would get it as 0, as it is plus 1, I have 1. This 1 is added here, 1 plus 0, 1. 1 plus 0 again, 1. 1 plus 1, 2 here. 2 plus 0, 2 here. 2 minus 1, 1. Plus 0, 1. Plus 0, 1. Minus 1, 0. That's it. That's it, right? That's it. I got it. Alright. I got the array where those which are not illuminated are 0. Right? This is how the sweep line algorithm works. Sweep line algorithm works. Where the event or the place where the illumination starts is marked +1 and -1 where it ends. It is ending at 6, right? So I placed -1 there. I would use the same thing, exactly same thing, and create this array of difference, right? Let us go with that approach. So first thing, what I am doing here is creating the difference array. So let me write the pseudocode vector of int with difference array of size n and having everything as 0. Now for every element in lights, for int I is equal to 0, I is less than n, I plus plus. L here is the minimum of 0, comma, I minus lights of I. R is nothing but, what is the R? Here 3 minus 1 is, sorry, 3 minus 2 is 1 here. Now 3 plus 2 is R, 3 plus 2. 3 is I, 2 is lights of I. So maximum of, sorry, here it should be maximum. Here it should be maximum. Here it should be maximum and here it should be minimum. Right? So maximum of 0 and if it is going negative, I would select 0. Now I plus lights of I. From this, the minimum is n minus 1 or I plus lights of I would be selected as R. Now difference of L plus is equal to 1. I might get 2 or 3 at the same index, right? Here I might have 3. Then I would go to 4 minus 3, which is 1, and I also have plus 1 here. So that's why I'm writing difference of L plus is equal to 1. Difference of R plus 1 minus is equal to 1. But if you see, what if R is n minus 1? I would go out of bounds, right? So only if R plus 1 is less than n, then only do this. If R plus 1 is less than n, then only do this, right? I have the difference array. Now I'll get the length and also answer, right? Answer is equal to 0 and length is also equal to 0. For int I is equal to 0, I is less than n, I plus plus. But if you see, I didn't go with the prefix sum for the difference array. So let me do that. For int I is equal to 1, I is less than n, I plus plus, difference of I plus equal to, or yeah, that's plus equal to difference of I minus 1. Difference of I minus 1, right? There would be a need where we might need long instead of integer while defining difference array, but it's okay. It might not exceed 1 if I for the difference. I think it would fit, right? So for int I is equal to 1, I is less than n, difference of I plus is equal to difference of I minus 1. Uh, that's it. Difference of I plus is equal to difference of I minus 1. That's it. For int I is equal to 0, I is less than n if difference of I is equal to 0, then increase the length. If it is not 0, then there is some light. Then what we would do? We would do length is equal to 0. But before that, add the number of lights required. Answer plus is equal to ln plus 2 by 3. Return the answer at the end. Right? So I'll code this up exactly. Int n is equal to lights dot size. Then I would define a difference array vector of indifference of n comma 0 for int I is equal to 0, I is less than n. Wait, I is less than. Okay, I is less than n, I plus plus. Int L is equal to maximum of 0 comma I minus lights of I. Then int R is equal to minimum of n minus 1 comma I plus lights of I. Then difference of L is plus is equal to 1, and if R plus 1 is less than n, then difference of R plus 1 would be minus 1. Only if R plus 1 is less than n. If not, we don't require that. For int I is equal to 1, I is less than n, I plus plus. Difference of I plus is equal to difference of I minus 1. I hope it works. Int answer is equal to 0, ln is equal to 0. For int I is equal to 0, I is less than n, I plus plus. If difference of I is equal to 0, then length will be incremented, else answer plus is equal to length plus 2 by 3, and length will be made as 0, then return the answer at that. Let me run this first. My God, I don't know. Oh, wait a second. Let me debug this. I got 1 everywhere for difference array. Cannot be 1. Difference at I, difference of L is difference of L and I'm printing difference of L and R wherever I get it. Okay, at 0 I got 1. Sorry. I should do this only when excuse me. Only when lights of I is greater than 0. Sorry. I missed this condition. No, I don't need this. No, I got it. Output is 0, expected. Okay. Again here. If length is greater than 0, then I need to do this. Okay. Std out. Okay. I hope you got it, and if you have any doubts, please let me know. Everyone who are attending this live session. Bro, I'm following Striver sheet. What is your opinion? I'm good at basics. Let's talk more, brother. Sorry for interrupting the live. It, it's okay, bro. I think I'm not getting the live chat. Siddharth, E18, E83, big fan. Thank you. Thank you, Siddharth. Okay. Your name is Adi, right? Okay, we can talk later, and you can also DM me there. DM me there, right? So, yes, I hope it's good to go to the next problem. We would go to the next problem, but only when you have understood the first and second. Right? The third and fourth will be, and the fourth one much, will be having much explanation about the digit TP. I might not explain that today. I think I should create another video where I can explain you the digit TP concepts easily. Right. So the third one is easy, however. Third one you can easily understand that by having the DFS, classic DFS problem. It's a classic DFS problem. Let me know how many of you have solved all the four problems. Right, and how many of you are from Hyderabad? Let me know. So I hope we are good to go to the next problem. Finish time of task 1. Right. You are given an integer n representing the number of tasks in a project. It is just a simple problem. Let me explain you the third problem simply. You are given with a tree. You are given with a tree which is having like this some children. some n children. It can also have more than two children as it is a tree. It is not a binary tree, don't worry. Leaf task is finish time is base time of I. Let me write. For leaf, finish time is base time of I. Base time of I. Now what is it for non-leaf will be having earliest and own duration. Non-leaf. Earliest, earliest, okay. Latest. Earliest, latest. And finish time is, I'll also tell you finish time, but own duration is latest minus earliest plus best time of I. Own duration. First, let us define what is earliest and latest. Minimum finish time among its children. It is minimum finish time among its children. Among its children. Maximum finish time. Maximum finish time among its children. Children. Alright. And what is the own duration? Latest minus earliest plus latest minus earliest plus best time of I. Now, finish time of task I is latest plus or own duration. So, we need to find out just earliest and latest. That's it. No need of worrying. Finish time is equal to latest plus own duration. Now, imagine a node like this. From all its children means this one, this one, this one, this one. From all this, I need the minimum. What is it? Minimum and also the maximum finish time. For leaves, I know the finish time is base time. So this is the base case. Base case. This would return the time, and this would have latest and also the earliest. And it would have from this I can get the finish time. This finish time I would return here. And let me tell you, let me tell you one thing. Here, here I have this finish time, right? From this, I would have the latest time and also the earliest time. I would calculate that finish from the finish time. Now I'll return the latest and the earliest also to this node or the upper node. Now here I would get the finish time. I would compare this with the latest and also the earliest. Now this latest and updated earliest will be returned to the parent node. For this I need the finish time. For this root node or node number 0. How do I code this? This is a classic DSS approach, but the only thing is having know what is the latest and what is the earliest. That's it. Let me write it. I need a DFS where I would get the latest and also the earliest. I think you can understand it with the code, right? right? So let me explain you again this. There are two children for this, three here, again two here, one here, and then three. Let us take three here. Here, what I am taking is minimum child, maximum child. I would update if it is having, imagine this is having a base time. This is having a base time of 3. Let me write it inside. 3. This is having 8. This is having 2. Now, minimum child will be updated from infinity, maximum child will be negative infinity. From what is the minimum child from infinity and 3? 3. What is the minimum child? If I also update maximum child. Negative infinity is the maximum child. I would update it to 3. Now I have 8. From 8 and 3, what is the minimum? 3 itself. From 8 and 3, what is the maximum? 8. From 2 and 3, what is the minimum? 2. From 2 and 8, what is the maximum? 8. That would be returned from these three. I have minimum child and also the maximum child. Now, this is the latest and earliest, whatever it is. Let me tell you how do I get this formula. So, instead of writing it like this, latest, what is the own duration? Latest minus earliest plus latest, sorry, base time. That is not best, that is base. Sorry, base time of I. I think we should not place it like this. This is having a base time of 2. Let me place some numbers so that you don't confuse. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, in the base time, I have 9, 10, 11. I have 3, 8, 2. Imagine for 0, 1, 2, 3, 4, 5, 6, 7, 8. I have 1, 2, 1, 3, 1, 2, 1, 1, 3. Okay, let us just think like that. Or let me change 4, and here I would change it to 6, something like this. Right? Now, here it is leaf, so it is just having the base time. This is the base time array which is given to us. Right? Now, at node 7, I have 1. So if I just simplify this, I would get latest plus latest, 2 into latest minus earliest plus base time of I. Do the same thing here. Do the same thing here and return upside. Excuse me. So what is the finish time here? Finish time is 2 into latest. What is latest? Latest is maximum child. So 2 into 8. What is earliest? 2 plus, sorry, it is minus. Minus 2 plus base time of 7. What is the base time of 7? 1. So 2 into 8 is 16 minus 2 is 14 plus 1 is 15. So this is having a finish time of 15. This is having a finish time of 15. Right? So I would return this 15. But wait, that is just a finish time of this one. I return from this. But what about this one? So here, for 8 I have 3, so I would return 3 here. And here also the minimum child. Here the minimum child or latest, earliest. Both are 3. Now the finish time would be, for 6 it is 1. So finish time here would be, let me calculate, finish time for node 6. How do I calculate the finish time of node 6? So 3 into earliest into 2 into earliest, sorry, 2 into latest, which is 3, minus latest, which is also 3, plus what is the base time of 6? 1. 2 into 3 is 6, minus 3 is 3 plus 1, which is 4. So here the finish time is 4. Here the finish time is 15. From 4 and 15, what would be the latest and what would be the earliest? The latest would be from 4 and 15. The latest would be, let me tell you, the latest what would be the latest? Latest would be 15. And the earliest would be 4. What will be the finish time here? Finish time would be 2 into latest 30 minus 4. 30 minus 4, 26 plus base time of 2, 6. 26 plus 6, 32. Right? That's the finish time for 2. That's the finish time for 2. Now, so 3, 4, 5 all are having 3, 4, 2. 3, 4, 2 as the return times. Here 3, here 4, and here 2. From this, the latest and the earliest. Earliest is 2 and the latest is 4. The finish time would be calculated as 2 into 4, 8 minus 2 is 6 plus base time of 1, 2. Right? 8 minus 2, 6 plus 2 is 8. So finish time is 8. 8 and 32, the latest one would be 32 and the earliest one would be 8. And what would be the finish time here? I hope you understood this, and if you have understood, let me know. 64 minus 8 is 56 plus 1 is 57. That's how you solve this. Just return the finish time. That's it. So DFS of something. Let me tell you. Let me tell you how I would get it. DFS of int u, and I have base time. It is nothing but a vector of int base time, and also the graph where I store it in MP. So unordered map int comma vector of int. Name it as MP. I have named it as MP. You can name it as your convenience. If it is empty, MP of u is empty, then we should just return base time of u. Else, I would go to the all of the neighbors, but before that, int minimum child is equal to int max. I think we need a long max, long, long. Let us initialize it with long. Long minimum child is equal to int max child is equal to int min. Sorry. Again, I'm doing the same mistake. L long max, right? L long max. L long min. Right, minimum child, and I also have maximum child. For auto neighbor in MP of u int, the time will be, or let us just take long. I think I don't need long. Yes, I need long here. Long t is equal to dfs of int, sorry, neighbor comma base time comma mp, right? Now the minimum child will be minimum of minimum child comma t. Maximum child will be maximum of maximum child comma t. That's it, right? Now I would just return 2 into what is the latest is the maximum child minus minimum child plus base time of u. That's what I return in DFS. Or just latest minus earliest, latest plus latest is 2 into latest minus earliest. That's the same thing what I wrote. So we need to construct the unordered map. For that, let me tell you, I'm just memorizing it. Let me tell you, how do I call it? DFS of 0 base time comma empty. Base time comma empty. Just return it. Right? So for MP, I would create it as for auto edge in edges int x comma y. X will be edge of 0 and y will be edge of 1. Int x is equal to edge of 0 and y is equal to edge of 1. I'll just create mp of x dot pushback y. That's it, right? That's it, right? For all of this. Now, there is only lineage from top. There will be no directional graph like bidirectional graph. Right? There will be only from top to top, the parent and the child. I also have to initialize unordered map int comma vector of int mp till here. That's it about the third problem. I know you might be having some doubts. If you have any doubts, please let me know. If you have any doubts about the third problem, please let me know. Now, what are the changing things? First thing, the node, which is you, right? And the time. Yes, that's just DP of You right? Nothing but I'm just storing in an unordered map, just memorizing it. So I hope it's clear for you. Till now, I don't know how many of you have attended this biweekly contest or make a separate video on the fourth problem. Some of these are not visible. Shiva Venkata Satyanarayana Varaga. If you haven't subscribed to my channel, please do subscribe. Yes, we already hit 1039 subscribers. We just increased 4 subscribers, right? We just 61 other subscribers to hit 1100 subscribers. Don't know. Hello, bro. Why does this our reach tracking? I don't know why. But hello. Why is this again retracted? Don't know why. Some of the messages are being retracted. Again, this one message retracted. Why I couldn't understand this. God. So if you have any doubts, please let me know. All right. There is some issue with this live stream. I don't know what. Audio rate is good, however. There might be some other thing for this finish time of task one. 39,000 people have attended this contest. So we'll be ending this contest in 4 minutes. So if you have any doubts about today's contest, please let me know. We'll be ending this contest sharply at 11 p.m. Let us read at the hints. Will the children list since the trees together and each has already points from parent to child. Computer finish times using a post order DFS, just post order DFS. So all children of a task are placed before the task itself. For each non-leaf task, keep only the and maximum finish times among its children. Other people are usually so they Innovate 12 people solved it. Yes. In contest, I have taken Intamin and Intamax instead of a long min LR. That's why I passed 995 and resulted of the contest. Assuming we will get part 2 in 10 hours, any idea how it might look like? I think the constants are, yes, that's, I also got that question. How it would be in part 2? Now there will be a part 2. Previous two questions were forwarded something. Let's be honest, if CP history has a cheating leaderboard, then I am sure that today's contest would just top it. It would break the scoreboard as well. 12K people solve this problem. Yes, there is one thing L long max and L long min give you the wrong answers, right? Previous questions were so good that I did not even read this question. Like, whoever is setting the question must be crazy. Simple DFS, storage TP. 12K people already solved. Guys, we ready for tonight's fourth one, which can be part of one fourth hour. Where you have written the list of withdrawal array of size and where array of I return the finish time of ith node if ith was selected as. Okay, right. There might be problem like this, right? Node will be the finish time. I think no. Why? Because we're already getting the DP of US latest plus. Oh, we can just return the DP vector itself. This annotated DP, annotated map converted into a DP and we can just return it. I think there might be something bigger for part two. Even a new way to mistake lives. 998 by 999. There are two types of people in comment section. One thing that either they are dumb if they aren't able to solve it. They think others have used AI to solve it. Because it was an easy question to get answers with AI. I do think that this problem was really simple and beginners are complaining here. I should say it's not really hard, but below medium problem to solve on trees. Practice tree traversals first, then pick this one if you aren't able to come up with solution. Initialize latest with 0. 0 of -1 e18 integer overflow. I submitted it and then I saw that I'm just bro. Anytime you see long, just initialize everything, even this native infinity or 1e minus 18, whatever, to L long or long. Because there might be a case, there will be this integer overflow. So yes, we are already, the time is already 11. Is here because traceability is guaranteed, which makes possible for a value to occur again in DFS. I got 990, I had my 9. Missed by one, stuck in some stupid test cases. Where's this one call of second one? Okay, so I think we are good to go now. So that's it for today's contest. And if you have any doubts, you can just comment or follow me in Instagram. Let me give you my Insta profile. Right, wait a second. So we'll be ending this contest. So I've given you the Instagram link. I'll also give you the link there. www.linkedin.com/in/r size. I've also given you the LinkedIn. You can just send me a request and I'll accept the request. If you have any doubts, you can ask me there. So thank you everyone who attended this live session. Thank you.